So now let's talk a little more about the importance score. Let's ignore the idea in the random surfing of getting bored for now. Okay, and we'll return back to our initial example with 4 nodes, which we just ran an in-degree version of importance on before. And so each node, we're going to say, has its own importance score. Okay, so they have their importance score, and we can use lower letters for that. So for big W, we'll say the importance score is W, or little w. For X, we'll say the importance score is little x. For Y, we'll say it's little y. And for Z, we'll say it's little z. And so now we have to figure out what are the chances that each of these links are going to get visited. So it's very simple, is that if we're on node W, okay, we only have 2 choices. Okay, if we ignore the idea of getting bored and surfing randomly, okay, if we're on W, we're going to follow the connectivity of the web graph. We're going to make that assumption. So we have to choose one of the 2 links. We either choose this link or we choose this link. Each of them is going to clearly have 1/2 of a chance because there's 2, right? So it's like flipping a coin. Just choose one of the 2. Similarly, if we're already on node Y, for instance, Y only has 1 outgoing link. So it's only one choice that you have to go to Z next. So this is actually a chance of 1. But now, as we said, we want to figure out how important the links are. And that's going to depend upon how important the node is itself. Okay, so we, in a sense, need each of these nodes to be spreading their importance score to these links. So it should make sense then that we should multiply this by W and say, well, this link is 1/2 W. This other link right here is also 1/2 W. And in that way, then we can look at this much easier and say, okay, well, when we're at W, W starts with an importance score W. Then this link is half of W, 1/2 W. This other link is another half of W because there's 2 of them. So W gets divided by 2, and we say it spreads its score to those 2 links. And similarly, for Y, there's only 1 link right here, so all of Y's importance gets put off on this 1 link. Okay, and so the reason is, first, we're splitting half and half on each of the links, and second is that we have to weight by the importance in the first place because that's how important the node is itself. So the more important node W is, then you see the higher the importance of each of these links will be. So if W is a very important node, then that'll mean that a link from W will be very important, and you see that's why there's this W factor in here, which takes care of that, of weighting the importance of the nodes on the links themselves. So as we said, each node has its own importance score, and they spread an equal amount of its importance to each outgoing link. And so we can also say that that's related to the out degree of a node. So we talked before about the in degree, which was the number of incoming links, and we used that as a measure of importance. But now we're actually using the out degree as well, and we're saying that basically we're dividing, and each link gets a fraction of the out degree, right? Because if the out degree is 3, then each link gets a third. If the out degree is 4, then each link gets a fourth of the importance score of the node, and so on. So it's just a way of looking at it. This out degree of W right here is 2, so each of these gets 1/2. The out degree of Y is 1, so each of these gets 1. The out degree of X is 2, so each of these would get 1/2 X, 1/2 X. We can write those equations. And the out degree of Z is 3. Because Z gets divided 3 times. So each of these is 1/3. We have 1/3 Z here, 1/3 Z here, and 1/3 Z here. Now notice that if you add what's outgoing, you will get the importance score in the beginning. And that's, again, the idea of spreading. This is 1/3 Z, 2/3 Z, 1 Z if we add all those up. 1/2 plus 1/2 is 1. 1/2 plus 1/2 is 1. 1 is just equal to 1. And so that's what that whole conservation principle, that we're only spreading the amount of importance. Each node is only spreading the amount of importance that it has to begin with.